Quick review here of Chapter 4. We started out the chapter with our sine and cosine graphs. So sine, critical points at 0, mark that on here, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Our generic curve goes up to 1 and down to negative 1. As these 5 critical points, our sine curve goes up, back down, down low, and here. So we use those 5 critical points to sketch one period, and everything is based off of those. So that's y equals the sine of x. Y equals the cosine of x. Very similar, same 5 critical points. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Also goes up to 1 and down to negative 1. Shape is different. So cosine starts up high, comes down through, minimum, back up, and up. So you can see our cosine curve sketches something like that. So there's our 2 generic curves for sine and cosine. Y equals sine of x, y equals a cosine of x. From there, we expanded and looked at variables that can change what the curve looks like. A, B, C, and K. So y equals K plus A times the sine of BX plus C, and y equals K plus A times the cosine of BX plus C. We'll start just going from left to right here. K is the vertical translation. Basically a constant that acts alone. It moves the entire graph up or down on the y-axis. A is the amplitude. So if these up here, these 1s and negative 1s would change, that's when our amplitude changes for sine and cosine. Our graph went up to 2, and then the negative 2, our amplitude would be 2, and so on. B affected our period length. And that equation or formula is 2 pi divided by b. That allowed us to find the period length. And C is referred to as a horizontal translation. It moves the entire graph either to the left or the right on the x-axis. It works in conjunction with the period length to change critical points, which gives us something called a phase shift, which is negative C divided by B. So on your test tomorrow, you will have, I think 4 questions that ask you from this equation to identify your vertical translation, your amplitude, your period length, and your phase shift. So for example, if I said y equals 3 plus 2 times the cosine of, let's just go 1/2 x plus pi over 3. Your vertical translation would be 3. Your amplitude would be 2. Your period length would be 2 pi divided by 1/2, or 4 pi. And your phase shift would be negative pi over 3 divided by 1/2, or negative 2 pi over 3. Very quick calculations there for period length, phase shift, amplitude, and vertical translation. We had another graph or set of graphs. And those were tangent and cotangent. So we'll sketch those very quickly here. Tangent had a left asymptote line over here at negative pi over 2. Had a right asymptote line at positive pi over 2. and we had critical points in between at negative pi over 4, 0, and pi over 4. So this is negative pi over 4, and this is pi over 4. And our graph went through those points, approaches, gets closer and closer, but never touches the asymptote line. So our asymptote lines are where tangent would be undefined. And then our graph looks something like that. It continues on forever, up and down. We have our quarter points here at pi over 4 and negative pi over 4. Quarter and 3/4 points, I guess I should say. For cotangent, we had a very similar looking graph, but it does go down from left to right. Critical points, pi over 4, pi over 2, 3 pi over 4, and pi. Our first one, our left asymptote line here is right on top of the y-axis, or at x equals 0. Our right asymptote line is right here at pi. We have an amplitude of 1. Our graph goes down from left to right by using the quarter, mid, and 3/4 points. And as we mentioned with tangent, our graph gets closer and closer to those asymptote lines, but never touch or never cross. So here y equals the cotangent of x. Pretty much the same values apply to tangent and cotangent that applied to sine and cosine in terms of k, a, b, and c. K is our vertical translation, A is our amplitude, B is our period length, C is our phase shift, or our horizontal translation. Works with B to be the phase shift. Couple of quick differences here. The only place you'll see the amplitude change for tangent or cotangent are at the quarter and 3/4 points. So if those coordinates change, for example, here if I had pi over 4 and 2, that means my amplitude is 2. You'll see that's the only place you'll see those happen. If there's no terms written here, then our amplitude is assumed to be 1. And the other big change is our period length is pi divided by b, not 2 pi divided by b like it was with the sine and cosine. Other than that, vertical translation, amplitude, everything else remains the same. We use our argument to find critical points, so bx plus c. I want to find where with tangent equal negative pi over 2, bx plus c equals negative pi over 4, and so on to find critical points. That also applies to the sine and cosine curves. Our last set of graphs were the cosecant and secant, so y equals a cosecant of x. Cosecant is simply based off of our sine curve, so we have pi over 2, pi, 3 pi over 2, and 2 pi. Same critical points as sine, reciprocal functions. Goes up to 1 and down to negative 1. The difference being is, although we would probably use our sine curve to graph that, we don't need the entire thing. Anywhere the sine curve crosses the x-axis, we have an asymptote line. So those places, and then our maximum and minimum serve as vertices of parabolas that would open up and down along those asymptote lines. Again, approaching but never touching or crossing those asymptote lines. And y equals the secant of x. No, reciprocal of secant is cosine. So we'll use our cosine points. Pi over 2, pi, 3 pi over 2, and 2 pi. Up to 1, down to negative 1. Plot those points, cosine. Hopefully we're well enough versed on that now that we can plot those points fairly quickly. Anywhere we have a cross in the x-axis, we have an asymptote line. That creates a half of a parabola on this side and on this side, and a complete parabola that opens down here as well. And we'll put this up here one more time. Y equals k plus a times the cosecant of bx plus c. Same effect. K is our amplitude, or our vertical translation. A is our amplitude. B is our period length. C is our horizontal translation. I'll write both of these up here again. Phase shift negative c divided by b. That also applies to the tangent and cotangent, although I didn't write those. And then our period length, since everything here is based off of sine and cosine, we're back to the 2 pi over b. So you should notice is that our functions 4 of the 6 use 2 pi divided by b, tangent and cotangent use pi divided by b. So the bulk of our test will be on graphing. We'll have one graph of each function. You'll graph a sine, you'll graph a cosine, you'll graph a tangent, you'll graph a cotangent, you'll graph a cosecant, and you will graph a secant function. You'll do one period of some of those, 2 periods of another. You might have a third period, I'm not sure, but at least 1 or 2 periods of each. We should know by now that all of our critical points are going to be spaced the same number of units apart. Oh, past that, I mentioned 4 questions on phase shift, period length, amplitude, and vertical translation. A couple of random questions. If I gave you a period length of 3 pi and an amplitude of 6, then write a sine function. Well, y equals 6 times the sine, and our period length affects the b value, so there is no c here. We just say 3 pi over 1 equals 2 pi over b, cross multiply 3 pi times b equals 2 pi times 1, solve for b by dividing by 3 pi, and b equals 2/3. So that equation we're looking for will be y equals 6 times the sine of 2/3 x. Or I might give you an equation that says y equals 5 minus 2 times the sine of 6x plus pi over 3. I'm going to say what's the highest or maximum value here? Well, from our amplitude, we go up to 2 and down to -2. It's a negative number, so it's a reflection, but it still goes up to 2 and down to -2. But then we shift that entire graph up 5, so our maximum value actually goes up to 7. The 2 plus the 5 to get 7. So there are a couple of random type questions like that. And then we would end the test with what we did yesterday in class. We would take and give you a picture of a function. Oh, I might give you a graph that looks like this. And maybe you have this point here at pi over 3, and this point at, we'll just say 7 pi over 6. We'll go up 1, 2, 3, 1, 2, 3. We want to find a function of that. So that could be either a sine curve or a cosine curve, and you knock those off one by one to find A, B, and C. A is pretty easy to pick out. That's by visual inspection. We can see how high and low the graph goes. B is that period length. Remember yesterday we marked that into a 3-step process. The distance between 2 critical points. And those critical points are called our x values, so values on our x-axis. Second step, we translate that to a full period length. And finally, step number 3, we set that equal to, in this case, 2 pi divided by b, or if we had tangent or cotangent, we set equal to pi divided by b, and solve for b. So real quickly here, just to kind of mirror that, our 2 points here are 7 pi over 6 and pi over 3. So I would subtract those to find the distance. That would be 7 pi over 6 minus 2 pi over 6, or 5 pi over 6. That distance is from here to here, and that would be 3/4 of a period. So we'd solve for a full period by multiplying both sides by 4/3. That way this side gets period by itself. 4/3, and since I just made up numbers, we get kind of a goofy looking thing here, but we have a full period of 5 pi over 9, so we're through step number 2. That's a full period length, and then 2 pi over b equals that 5 pi over 9, and cross multiply to solve. 5b, or 5 pi times b equals 18 pi. Divide by 5 pi, and b is going to be 18/5. Again, because I made up numbers there, we got kind of a goofy looking fraction for b, but that's the process, three-step process. Hopefully that makes it easier. And then once we had that, we put that in our argument, 18/5. We're going to substitute x value in, and here's where we have to know what our graphs look like. We'd use pi over 3, the closest one to 0. Pi over 3 is coming down through the x-axis, so if we're using sine, sine comes down to the x-axis of pi. If we were using cosine, cosine comes down to the x-axis of pi over 2. And when I say comes down through there, I'm talking about the generic curve that we drew up here to start our section. And we go ahead and solve for c based on those arguments being set there. And you'll have, well, probably one similar to this, and you'll probably have one that might be a tangent or a cotangent function. But I believe that would cover pretty much everything that you would see on the test. As I said, it's fairly graph intensive. There's probably only 13 to 14 questions, and 6 of those are on the graphing side of things. So make sure you know your critical points, your shape of each graph, and that should allow you to graph. You have a worksheet with 1 through 10 on these types of problems. Today you should get an additional worksheet that has, I think, probably 4 or 5 more of those. There's plenty of practice. The answer keys are on the desk up front. Work through those. Make sure you check and see if you have any questions. And there will be that review assignment posted on the board as well as preparation for the test. So hopefully that covers everything that you will see.